In this quick review, we want to just talk about the basics of probability, how you compute a probability, and then some very, very simple examples. Okay, so first off, how will we compute probability? To do this, we'll use what's called the classical method for computing probabilities. And that formula just looks like this. We use P to denote the probability, and then in parentheses, I'm going to put the letter E. Okay, what this means when you see something like this, it's saying the probability of event E. So what is inside the parentheses is what we're looking for. It doesn't mean P times E. So this is probability of event E, or the probability that E occurs. Okay. And it's a very, very simple fraction. Right? What goes in the top, what goes in the numerator is just the number of ways E can occur. Right? Just the total number of ways E can occur. And what we divide that by is the total number of outcomes. Like for example, when you think about when you flip a fair coin, what's the probability you get heads? Well, the number of ways you can flip heads is one way on a coin. And the total number of outcomes, well, there's two. You can flip heads or tails. So that would be 1 out of 2. So this is the basic formula we'll use for the following 2 examples. Okay, here's the first one. Suppose you flip a coin 3 times in a row, okay? And then you're going to record your results. All right, so first off, it says how many possible outcomes are there? And this is how I'm going to show the outcomes. Well, one thing you could do is you could flip heads 3 times in a row. And what that would look something like this. I'm going to write it like this. H, 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 H. Head, head, head. And then there's all these different outcomes. You could flip tails, 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 tails. You could flip head, tails, tails, and so on. You could flip tails, head, tails, all these different outcomes. So what we want to find is all the possible outcomes. And for a little trick here, what I'm going to use what's called the tree diagram. All right. And what this does is this uses basically you construct a tree, and all the branches of the tree are going to represent the possible outcomes. So the way I like to think about it like this. You're going to flip the coin the first time. You could get a head or a tail. So the branch represents the possible outcomes. Then you know what you're going to do? You're going to flip a coin again. Well, on the second coin flip, you could get a head or a tail. Hey, but what happens if you flip tails first? Well, on the second coin flip, you could get a head or a tail. And then finally, when you go to the third coin flip, well, maybe on the first flip you flipped heads, second you flipped a head. Well, then on the third, you could get a head or a tail. Maybe you flipped a head, then a tail. Well, then you could get a head or a tail. And so you can see, each branch is going to represent all the possible outcomes. And so what our outcomes are here this is also referred to as the sample space. But I'm going to traverse the branches to see. So the first thing that could happen, I could flip head, head, head. I could flip head, head, tail. I could flip head, tail, head. I could flip head, tail, tail. These are the outcomes in which heads I flipped heads first. Well, I could have flipped tails first, so I could have got tail, head, head. Tail, head, tail. Tail, tail, head. Or tail, tail, tail. And what I see here is there is 8 possible outcomes to this probability experiment here. All right, so now let's ask some questions. We got all the possible outcomes. What is the probability you flip all heads? So I'm going to write, what is the probability of all heads? What this means is I basically flip 3 heads. All right. Well, it's the number of ways you can flip all heads. So let's look at our outcomes. There's only one way I can get all heads. And how many total outcomes are there? There's 8. So this would be 1 out of 8. I'm going to show this as a fraction, or you can plug this in your calculator and it would actually become 0.125. Okay, so that's the probability. It shouldn't be noted that probabilities are always going to be between 0 and 1 inclusive, which that is, so it works out perfectly. Next, what's the probability of exactly 2 tails? All right, simple fraction. Well, let's go back and let's look through here. How many outcomes have exactly 2 tails? Looks like this one has 2 tails. This one has 2 tails. And this one has 2 tails. Not this one, right? This one here has 3 tails, so that's not exactly 2 tails. So it looks like the number of ways that could happen, which would be 3, and the total number of outcomes is 8. So this would be 3/8. Or if you would plug this in your calculator, you would see it would become 0.375. All right, let's try another one real quick. All right. Suppose a fun-sized bag of M&Ms contains 9 brown candies, 11 yellow candies, 7 red candies, 4 orange candies, 2 blue candies, and 2 green candies. So just this fun-sized bag of M&Ms, just so we realize the total number of candies, if you were to add up all those numbers, 9 and 6 is 15, and 7 is 22, 26, 28. There are 30 candies. Right? Suppose that a candy is randomly selected. First question. A, what is the probability you reach into the bag and you get a yellow candy? All right, well, just using the classical definition, well, how many ways can that happen? Well, there's 6 yellow candies. So there's 6 ways you could pick a yellow candy out of 30 total candies. Like this, 6 divided by 30, if you would plug this in your calculator, you get 0.20. Next question, what's the probability you reach in? All right, and the candy you get randomly selected is blue. Well, how many blue candies are there? There are 2. How many total candies? That would be 30. So if you were to plug this in the calculator, you would get 0.06666666 repeating. So I'll just round it like that, 0.067. All right, last question. Comment on the likelihood of the candy being yellow versus blue. We'll notice that it's significantly higher odds that or higher probability that you would get a yellow candy versus blue. And the likelihood is asking you basically how many times more likely is it? Okay, what would you have to multiply this by to get this? And what you would see here is it's 3 times as likely to get yellow versus blue. Okay, I hope this quick review helped. Just remember, using the classical definition, it's just the number of ways a certain probability or a certain event can happen divided by the total number of outcomes. As always, if you have more questions, please reach out to your instructor.